Now, if we ignore air resistance, and in this course we always ignore it, all objects fall towards the Earth with an acceleration of 9.8 metres per second squared. And this is gravity, and this is the figure that we have for our planet. It would be different somewhere else, for example on the moon, it's about a fifth of this. Now, we sometimes round this to 10 metres per second squared, and the question should specify which value you need to use. So, in all of the questions that involve falling objects, we've got a starting point now. We can say that acceleration is 9.8 metres per second squared, or we can say it's minus 9.8 metres per second squared. And we can use the given clues to find equations for velocity and displacement. Now, why can we choose whether to call it positive or negative? It makes sense that if something's falling towards the Earth, then the velocity will be negative. So the change in velocity over time should also be negative. And that's true. By rights, acceleration is a negative force, okay? On the other hand, this part in red here explains you can decide on the direction that will be positive, and you can decide on the location of the origin, both things, based on the context of the question. Now, how is it that you're able to decide? Well, generally these sorts of questions will give you a worded question, and you need to give a worded answer that makes sense. How you work it out is up to you, and if you want to deal just with positive numbers, there are many instances that can help you to do this. Let's consider this example. We've got a rock falling from a 50-metre cliff. Now, if I get to decide where the origin is, I might choose to set up my question so that here's the cliff here, and it's 50 metres tall, and so on my vertical axis I could have the heights here and call 0 the place where the rock is going to land, at the bottom of the cliff, and 50 could be the top of the cliff. Somebody else beside me working on the same question could say, no, the top of the cliff, we'll call that 0 because that's where the rock started, and when it falls down, we can call this minus 50. Which one should you use? Well, it's completely up to you. And because of the nature of the way you're going to use your information to integrate and find your velocity and displacement equations, it's not going to matter. It's going to work out with the same answer as long as your worded answers end makes sense. Now clearly we get to decide whether to use 50 and 0 or 0 and negative 50. I'm thinking this one potentially could be easier just because it's positive numbers. On the other hand, if they just said a rock falls from a high cliff and I don't know how high it is, then it makes sense to call the height 0, and when I'm finding out how long it takes to do something, if I don't know where the bottom is, it makes more sense maybe to go with this option. All right, what about the direction that positive is going to be? Well, if you've got something that's going up and then down, like a ball that you've thrown up and down, or even if you've thrown it down and then it's bounced up, probably makes sense to stick with positive being up and negative being down so that you don't get confused. Similarly, something that's moving left and right on a number line, I would keep positive being to the right and negative to the left so that it's really easy to understand. On the other hand, something that's only moving in a negative direction and it's not bouncing back up again, perhaps we don't need to consider that. If I decide that going this way is going downwards a certain positive number of metres, well then I can say that I'm moving with a positive velocity and with a positive acceleration, and it just allows me to use positive numbers in my calculations. After all, I can say that I'm moving downwards with an acceleration of 9.8 metres per second squared, or I can say that I'm just moving with an acceleration of negative 9.8, which automatically builds in the fact that I must be going down. So it's up to you. The key thing to do is just to make sure that your answer is really clear and that's actually answered the question and it makes sense. So in this example, a stone is dropped from a tall building. It doesn't say how high the building is. How far has it travelled and how fast is it going after 5 seconds? Well, let's assume that the building's tall enough that after 5 seconds it hasn't actually hit the ground and been stopped, because otherwise it'd be very hard to know what's happening. All right, so I've got a choice of where to make the origin and which direction is positive. I'm going to choose to work with positive numbers here and say that I'm starting from 0 and then I'm getting more negative, but the distance travelled can be positive. So how do I set that up? Well, let's just let 9.8 meters per second. Okay, so that means it's a positive acceleration, but in a downwards direction. I know from the context of the question that I'm going down, and I'm not going to bother building that in. All right then, so to find v, I need to integrate this, don't I? So to integrate, I'm going to get 9.8t. Notice how when I'm integrating with respect to time here, there was no time in it, so this is a constant, and now I just add my t, but I need plus c on the end. All right, let's consider the initial condition. It wasn't really spelled out, but I think we can assume that before the stone was dropped from the top of the tall building, it was still there. So in other words, I know that when time was 0, the velocity was 0, because I don't think this stone was moving until it was dropped. Therefore, I can sub these both in and say 0 is equal to 9.8 lots of 0 plus c. So clearly, c equals 0. Now I can write my v statement again with more confidence because I've worked out that there is no constant on the end, it's just plus 0. Okay, now I have velocity, I can find displacement. Because I want to find how far it's gone, so if I want to see where something is, I need to know the displacement. I also want to know how fast it was going, so this will help me. Okay, so to find x, I need to integrate this again. So the constant comes along for the right, we raise the power by 1, divide by the new power. Then we need to add our plus c. Now we could also write this just by simplifying here, and we could say it's 4.9 t squared plus c. All right, we need a clue to work out c. Well, the initial condition was that before that rock was dropped, it was, well, we can decide where it was. I think we should just call that point 0, the origin. So let's say when t was 0, x was 0. In with this case, we're sort of saying it hadn't gone anywhere yet. And now when we find where it has gone, we're going to see how far it's gone. Now, because we've got a positive expression here for the displacement, we'll have to bear in mind that if it's moved, say, 50 metres, we know it's gone 50 metres down, not up. All right, so now we can sub this in. Therefore, 0 is equal to 4.9 lots of 0 squared plus c. So clearly, the c is 0 again. That's handy. So now we can write x with more confidence. We know it's 4.9t squared plus nothing. We can leave that off. Now we've got our equations. I find it's handy to go back and actually just put a box around them so we know what we're using to answer our questions. How far has the stone travelled after 5 seconds, and how far has it gone? All right, so I'm going to write when t equals 5, in other words, after 5 seconds, x equals 4.9 times 5 squared, and that gives me, what is it, 122.5 metres. So that's how far it's gone. So it's obviously dropped that far. And when t equals 5, what is the velocity? Because that will tell me how fast it's going. Well, the velocity is 9.8 times 5. And that gives me, what do we have? 49 metres per second. All right, so to answer the question, I need to write after 5 seconds, the stone has fallen, what is it, 122.5 metres and is travelling at 49 metres per second. Now, how would I have done this differently if I hadn't defined acceleration as being positive? What would have been different? Well, let's take a red pen and have a look at how another person might have done the question. They might have said, let's start with knowing acceleration is negative. Therefore, velocity is going to be negative here. And we would have also had a negative down here for x. Then when we figured this out, we would have said that x is a negative number of metres. Well, that makes sense. If the top of the cliff or the building was 0, then when it's at minus 122, it's clearly gone down. And here we'd have a negative velocity too. But when we came to write our finishing sentence, wouldn't we write the same thing? After 5 seconds, how far has the stone travelled? Well, it hasn't travelled a negative 122.5 metres. the distance travelled sort of ignores the direction, doesn't it? We all know that it's gone down, so tell us how far it's dropped and show us how fast it's going. Because here, this question is really asking about distance and speed. And both distance and speed don't need direction into them. They're what we call scalar quantities. They're not the vector quantities of displacement and velocity, even though we use displacement and velocity to find them. And in fact, that takes us back to our original definition of distance travelled being the absolute value of displacement, in which case the negative out the front really doesn't affect anything, and speed being the absolute value of velocity. So even if we had found a negative, we'd still talk about the speed as being positive. Now, a quick note to the physics students. These formulas that you have used and derived in physics are not to be used in advanced maths. Now, it's handy if you know them, perhaps you can check your answers, but in this course we're expecting you to actually get from those formulas for displacement, velocity and acceleration by either differentiating to move downwards or integrating to move upwards.